It was Trinity's job in my 3M class to remind me every day. But I couldn't ignore her, kind of like I do you guys. Not that I ignore you guys. Yes.
Sounds like old minus.
X being the data point you're interested in.
Yeah.
Okay? Is the mean. And the line underneath is the... So, the... Yeah. Tomorrow is like a review of everything. You have no new topic tomorrow before the test.
So are we do here's another unit Thursday and Friday?
Yeah.
And Monday we get back, the day of the test?
Oh, let's take a look. Take a look at this. I gave you a schedule. The only time I ever gave you a schedule.
So wait, X is normal X.
X is just the point you're interested in. Okay? So a Z score... I'm recording now.
Yeah, but are you recording it so we can go back later and watch it?
Yeah. It's all in one note. Right? You'll miss the very first part here. But we're gonna go through like this example, then have another example we'll work through all together. Okay? So a Z score allows you to do one of two things. It allows you to compare two different sets of data against each other, right? In this case, we're comparing one person's grade to another person's grade and their relative strength of grade, right? Because if you look at the very first, Charlie's grade with a 84 seems to be stronger than Lauren's grade of 83. But if we want to compare them, we can do a Z score on it, right? And the way that works is we take the point we're looking for, X, we're looking at, in this case, Charlie right here, 84. We minus off the mean, which is 74, and we divide it by the standard deviation, which is 8, which in this case will give us 1.25. Lauren is 83 minus 70 divided by 9.8, which gives her 1.33. So who's actually stronger compared to their peers? Lauren, because her Q score is bigger. I mean, her Z score is bigger. No, you want a larger Z score. But this also tells you how far she is. Like if you're thinking like standard deviation points, like 1 standard deviation point, 2 standard deviation points, 3, she's at 1.3 standard deviation points. Does that make sense? Like if I draw this graph right here, we work with the 1 standard deviation, 2 standard deviation, but she's actually at 1.3. And we can actually use this number to figure out her percentile rank. Have we heard of percentile before? So I put this in your reference sheet, but it's also in your book. 1.33 is her number, correct? Mm-hmm. So if we go to our Z score table here and go to 1.3, right? I go to 1.3, then I'm going to go over because the number was 1.33, correct? So I go over 1.3, 1.33 is right there, right? So realistically, if I round it up, 0.9082 times by 100 will give you your percentile. So that's like the percent in as a number, 0.93, okay? 0.9082. But to get it as a percent, you times it by 100. So that'd be 0.91. Hello? Yeah, no problem. Okay? Then we times that by 100 to get the percent. So I'm going to round up to 91. No, but this is, it's not percentile as in percent on their test. It's percent of people in the class she was ahead of. So she got a better mark than 91% of the people in her class.
So it's 9 per mark.
No. No. So if there are 100 people in her class, she beat 91% of them. Well, I'm just using that. What if it was like this class? I go 0.91 times how many people in this class? 24. Did that make sense the second time I explained it, Diego? It's not your percent mark, it's your percentile mark. 0.91 times 24. Why would she be getting an award if 9%? Oh, I don't know. I'm not arguing the award part. Okay, Diego, why she deserves an award or not. So in this class, like if she was in this class, she would have got a better mark than 21 other students. 3 other students would have beat her. Sometimes the person who gets the highest mark does not deserve the reward. Pardon?
Like she got a significant amount higher than everyone else.
Yeah. I'm not arguing the reward. We're just comparing two kids.
Like that's
Yeah.
Sometimes the highest mark is just surrounded by mediocrity, so.
Right. So, now, you guys saw how I found that percentile, right? I went to the Z-score. Now, if you go in your textbook, 398, 399 is that exact same chart. Okay?
Our percentile is going to be on this side.
Probably, yeah.
Then are you going to give us the...
You get the chart, yeah. Yeah.
How long is the...
Relax, relax, people. Yeah. No. I'll show you the form of the sheet before.
You'll show it to us.
No. But that if you fill that out, you're pretty much, and just study that sheet and know how to do the stuff on that sheet, you're good. I agree, that's why I said study it.
Then can we have the sheet?
No. Okay.
Can you look at it?
Okay. Here we go. Let's work through a whole question for you. Okay? But this is all we like. This is the last lesson for today. Just a Z-score. Okay. So the mean age of viewers for a popular quiz show is 38.3. I don't have this on I didn't print this out. So you can do this on a piece of paper, right? So the mean is 38.3, okay? With a standard deviation of 12.71. You can work it through with me. Okay?
How is connected to that?
Which part?
Like doing the part on that number.
We found the standard deviation.
So this is another way of doing it?
No, this is using standard deviation.
Oh.
Right?
After
Correct. This is using, like this morning we used standard deviation. The second part was we understood what percentages were in a standard curve. Standard curve, right? And now we're applying that standard curve to understand questions. It is. You guys, it's tough. This is a tough course because we're putting like 3 days of work into one day. And you have to like learn like the first part to understand the second part to understand the third part.
Would you just put like 70 into the equation that we have?
Good. So the Z-score, what's the equation? X minus the mean over the standard deviation. Does that make sense to everyone? Mean. Yeah, it's the mean. Okay? So let you guys get ahead before I answer it?
So we put the 70 where the X is, right?
Yeah, because that's our data point, right?
Yeah.
So that'd be 70 minus 38.3 divided by 12.71.
70.
70s are data point we're interested in. Now we could also like, I'm sorry. No, we're not going to get percent. We're going to get a Z-score first. Right, and then we take our Z-score to the chart to find our percentile. 70 minus 38.3.
We have to memorize the chart.
No,
That's a lot.
yeah. So who else got 2.49?
No. Just do that. Are we allowed to do that? Round it up.
You want two decimal places. So, thumbs up, I was able to get that number? Thumbs up? Do you understand where the number came from?
No,
So our x, it's not fine. Our x number is the data point we're interested in, so that goes in for that number there, right? So our x comes from here, right? The mean comes from over here, and then the standard deviation goes here. So 70 minus 38.3 got me that number, divided by my standard deviation, which gives me this number. Okay? Now, I'm going to go one step further. Everyone, what page was that on? 33, turn your notebook, or turn your textbook to 398 and 399, and tell me that percentile number. So realistically, wait, before we do that, let's understand what that means. Stop looking, Megan. I called Megan. Megan. Alright? Wait a second, let's,
two different tables.
there's a negative table and a positive table. Okay, let's look at this number and understand what it's telling us. Okay? 2.49, okay? That number is a positive number, so it's going to land like here. Does that make sense to you guys? So this is your standard, like how many times over standard deviation it goes. So around here, we're at 2.49. So if you think about it, in your head, you're thinking this person should be like in the 90th percentile, like a very high percentile, correct? Because that's where that number lands on the standard deviation line. This is giving you how many standard deviations over it goes. The standard deviation number is what number adjusts this way. Okay? So what number did we get? Let me go look and make sure you guys are. So if I go to my reference sheet, I go to 2.39? 2.49. I go to 2.4 and I go over to 9. 2.4. Right? So I go to 2.4 and then I slide over to get to the 0.9. So 9936. Now if we times that by 100, we get our percentile. 99th percentile. Right? So that would mean of all the people watching that show, 99% of the people watching the show are younger. 1% watching the show are going to be older than 70. Pardon? Less than 1%, yeah, but I'm just rounding. Okay? Does that make sense? Alright, let's keep going here. What's the Z-score for a 20-year-old? Let's do the same thing for the 20-year-old. Replace the 70 with a 20, you're right. So to get my z-score, x minus x swift here. All right, thank you, Diego. I'll double check in a second. Maddie, what number's going to go? What number am I putting in here this time? 20? Yep. Then go to your table, and I want the percentile as well. What number goes next? Yep. Good. 20 minus 38.3 divided by 12.71, negative 1.4? 3? Do you guys get that number? Negative 1.43? Now think about let's connect it to our logic here again, okay? Think about where that's going to land on our chart. I should have really like copied and pasted a nice chart, eh? So that me draw my chicken scratch every time. Oh, that's a positive one. There's a 9 after the 3. Oh yes, that would be 1.44. That's fine. Okay. So if we take a look at it, what's our number? 1.44, right? So realistically, on our standard deviation chart now, it's going to land at negative around here, correct? That would be like negative 1.44. Does that make sense? Are you okay, Maddie, or not? Okay. So now, when you looked up your z-score there for percentile, what'd you get? Does anyone look it up? 0.0749. So what percent is that? 7.5% times 100. Yeah, just watch Diego. 7.5%, not 7.5%. Okay. So that would mean, of the people watching, he is people younger. 7.5% of the population would be younger watching it, right? And 92.5% of the people watching would be older watching. Does that make sense? That's why sometimes if you look at that chart, if I go back to my Q-score chart here, or my Z-score chart, sorry. If you look at this here, these are the positive numbers, right? And it's telling you the probability of it too, right? That means this many people are below this line, this many people are above this line in percent. Can you see that? Okay. I won't pass it out. You make a chart. Yeah. 100%. We need a ruler for. What's this? Uniform?
There's nothing there.
Yeah. Why would we use this in real life? This is the most applicable math this is honestly the most applicable math you've done, but you haven't been exposed to the situations when you use it. You'll remember. No, trust me. I remember, like, if you were to ask me like 2 weeks ago before I started doing the course about standard deviation, I'd have a rough estimation of how to interpret standard deviation. I forgot the formula. Because I went back and looked at it, now I remember.
Yeah, exactly. So why can't we have a cheat sheet?
You will have a cheat sheet. You have the formula.
No,
No, you don't have that.
yeah.
Okay, let's keep going. So, you guys are doing great.
Are we? Doesn't mean
Yeah.
we're gonna remember it.
Oh, here's a great question, which everyone could do.
What age?
Oh, sorry, I never answered your question. So, when would you use this? So, if you were in a situation where you had to analyze data, right? Which you could end up in a few, like what I'm talking about is jobs in the future.
Like what?
If you're doing risk analysis, if you're doing, like my wife does statistics with her research, right? If you're looking at the probability of things occurring, right? This is all applicable to that. If you work at a casino, if you're a statistician that works at a casino, if you're in pro sports is all statistics now for prediction, right? And so on and so forth. Yeah, but for you guys right now, you guys haven't been exposed to when you need this yet. When you read your first, I'll bring in an academic paper tomorrow. Okay? No, you won't forget it. You know, here's what I'll say. You will forget it, but the base will be there when you have to look at it. You'll pick up the understanding quickly. Okay? Yeah. Like there'll be you'll take a stats class in university based around like standard deviation and whatnot. Okay. Go ahead, Adam. Oh, like car companies do it all the time. We have this faulty part in the car. Should we fix it, or does it cost us more to fix it, or does it cost us more to pay the people who get injured by it? Okay? Alright, so, I see you, Megan. Go ahead.
And like the chart and whatever, how do we know like for the negatives and positives, like which one is more?
Well, negatives are always going to have the lower percentage, right? If
Yeah, but like how do you said that 7% of people will be wealthy or won't be?
will be younger.
Will be younger, but like how like
Well, because if you think about the chart that's here right now, like if you think about it like this, that exists right now, right? What was the average? 30. What was the average? What's the mean? 38, right? If this is age going this way, if his line lands here, right? The last guy we did, the 20-year-old. The 20-year-old, right? The people on this side of the chart, right? And this was 7.5%. This line happened at 7.5%. The people on this side of the chart are going to be younger, right? The people on this side of the chart are going to be older, right? You have to kind of logic it out and understand. But this is practice. That's why you do practice questions. Logic it out. Okay? So let's go here. What was my average again? Was 38.3, right? 38.3. What age range is within the 2 standard deviations of the mean? So if our standard deviation is 12.71, if we go 2 standard deviation points down, what's my number going to be here? I just chose to go left first. Yeah, yeah. I just chose to go down first. So this is a question like we did, like the previous chapter. What's the age there? 12.88. Do we agree? 12.88.
Yes, I agree.
So 12.88. And what's 2 standard deviation points up? 63.72, right? So there's your question. Like what age range? So the age range would be 12.88 to 63.72. So you could be 63.72 of a year, right? Fine. So I did the calculation here for you already for this one. This is School's Talent Show Contest. The mean age is 16.5. The standard deviation is 1.36. Yes. Correct. Yeah, I just went ahead and did it for you last night because I didn't want to see.
So that's
Yeah.
like,
This would be a question. Like this would be hypothetically. This is the hardest question you could get tomorrow.
this?
This.
Why is it hard to get? But that's fine.
No, it's not that hard. Have you guys done standard deviation?
It takes a long time.
It takes a long time, but you can do it,
Okay.
right? You guys can find the mean, correct? Then you can apply the logic. Like there's nothing out here that is above your mathematical capability. It may be challenging your mathematical grittiness, for lack of a better term, or how much effort you want to put into the work, right? But this is a quite doable task, correct? So, what's our 14-year-old? Norm's 14. He's lived 14 years with the word norm as his name.
Sometimes you hire 14 years.
So what's the z-score there? So can we figure out the Are you calculating or are you Snapchatting? Negative 1.83? Who agrees with that? We agree? Cassandra, did I see a nod from you? Now I keep writing this down because I want you to connect that number to like what we're looking at in the chart, right? 3.6. So realistically, 1.83 is going to be about like here-ish on our chart. Does that make sense? Is it 1.84? Diego's 0.338, so it's 1.84. Diego's on all over me with rounding here. Good job, Diego. Alright, so, what was the question? I got a question before I got distracted. How do we get the solid z-score?
Yeah.
What do you mean by a solid z-score?
That's not a z-score, is it?
That's the z-score.
But I thought we had to convert it.
We take our z-score to that table and convert it to percentile.
Okay.
The z-score is the decimal place number. That would be the answer there. And then if I asked here, we'll go backwards. That's a great question. All right.
So will we have to go backwards on the test?
Yeah. I don't know if we do or not, but it'd be good to learn. Okay? So, do we want to find the percentile there?
Sure.
Yeah. Look up negative 1.84 on your, what percentile do we have? 0.0329. Good. So times that by 100 to get 3.3%. I'll tell you how. I'll tell you what number. Right? So therefore, 3.3% on this side, correct? And 96.7% for the people on that side. Do you get that? Well, it's 100. All this whole area is 100, right?
Oh, and then minus.
Yeah.
So what side is which?
Well, this side here, like look at where see where I put the blue dot? It's here. So 3.3 is going to go on the short side, right?
Yeah, but like, what side is that? You know what I mean? Like you know how we just did the thing where it's like younger people and then like.
Oh, for this case, it would be younger people. Because they're age of participants, right?
So there's no young.
No, less, more older people, yeah. Okay? This is a good question. Yeah, it is. how did we get this number here? Yeah. So you took the standard deviation. I'm going to give you a question here. Let's do the 80 with a standard deviation of 5. Okay? If I asked you to give me this standard deviation right there, you guys all say 90, correct? How did you get the 90? You had a 5, so 2 times 5, right? Plus 80. You guys agree with me? Yeah. Is that a yes or a no? Okay. But how we did that was we went up 5 here, to 85, right? And we went up 5 again to 90. So essentially 2 times the standard deviation plus your mean, right? So realistically, I would draw something like this. What is my computer doing? It's rejecting math. Like, oops, wrong symbol. Realistically, if I were to draw this out like,
Is this to answer that question that's just above it?
yeah. So if you look at this, we did 2 times 5 plus 80. On this question here, if I asked for what's the if I had a z-score of 1.5, what percent did I get on my test? If I told you I was 2 standard, you go 2 times 5, correct? If I told you I was 1.5, what would you do? 1.5 times 5 plus 80, right? But that's my mean. Yeah. I took it away from that question. I did a simpler one. How would I do with that question? Well, for that question, I would take 1.5 times my standard deviation, which was 1.36, then add on my mean, 16.5. Right? But do you understand how, like the same thing, like if, okay? That's it for right now. I'm not going to give you the formative quiz right now. Although, let me look at it and see.
Can you give us for like homework? Yeah, like so we can.
Oh, you want to do it for homework? No. I'll do that. Yeah.
No.
No.
Okay, then no.
I'm gonna do it. I don't do anything.
Can it just be like a review thing, so it can be like optional?
Yeah.
We don't have to put it in.
Well, I want to do it in the morning. I'll show you the quiz. Stop recording.